Hi, I'm Sean Gann, and this is Minute Math, and today we're learning about integration by substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral of 36x squared e to the 4x to the cubed power plus 3 dx. And we're given a u value of 4x to the third power plus 3, and we have to evaluate this indefinite integral. Now our u value is already given to us, which makes it a lot easier, so let's go find our du value. Take the derivative here. Power rule, 3 times 4 is that 12, x to the second power, then we just have a dx afterwards. Now we have to see if we can rewrite this integral in terms of u, with what we have, our u and a du. Notice we have our u value, we can just put right up here, right? That's the whole point, that u. But we want our du, well there's a 36 there, and I want it to be a 12. Well, we know we can pull out a constant. So if I pull out a constant of 3 here, I'm left with 36 divided by 3, a 12 on the inside, x squared. Then we have e to the 4, x to the third power plus 3 dx. And notice again, our u value is still up here, but this right here, the 12x squared dx, is our du value. Now we can rewrite this in terms of u. We have 3 times the integral here. Now we have e to the u power, right? The u's are just up there. And then 12x dx is just that du. And that's a much easier integral to solve. So let's use our definitions here. An integral of e to the u is just e to the u plus c. So 3 stays out front. 3 times e to the u power plus c. And we keep on going. Now u, we can plug back in, is that 4x to the third power plus 3. So let's do that. 3 times e to the 4x to the third power plus 3, and then plus c at the end. And that's it. Our final answer here is just that 3 times e to the 4x to the third power plus 3, then plus c at the end. We're given this problem right here, the integral of 80x to the third power times 3 to the 5x to the fourth power minus 2 dx. And we're given a u value of 5x to the fourth minus 2, and we have to evaluate this indefinite integral. Now we're already given a u value, which helps. We need to find our du value. The derivative here, du, 4 times 5 is a 20, x to the third power, subtract the 1, and then derivative of negative 2, don't worry about it. We just have a dx at the end. Now look at this. We want to see how we can rewrite this to look, well, in some terms of u and du. Our u value clearly is the exponent right here, and our du is fairly close. Our du, we have the dx right there, we have x to the third, we just have the constant out front. That's an 80 and a 20. But if I pull out a 4 and bring it to outside the integral, right, pull out a 4 here, we have 4 times the integral, well, 80 divided by 4 is 20. We have x to the third power times 3, then 5x to the fourth power minus 2 dx. And again, our u value is right here, 5x to the fourth minus 2. But notice now if we combine the 20x to the third power dx, we have our du. So now we can, well, rewrite this in terms of u. We have 4 times the integral, not an s, the integral here, and then we have 3 to the u power, and then du is just that 20x to the third dx. Much easier to solve. Now, 4 stays out front. Let's go find the integral here. And the integral of 3 to the u, we follow our definition, it's like an a to the u power. So we have a that's equal to 1 over the natural log of our a value, in this case is 3, times 3 to the u power plus c. Well, we can rewrite this now and plug u right back in. So I put 4 on top, no, left outside. So 4 times 1 over natural log of 3, okay? Then multiply that by 3 to the u power, 5x to the fourth minus 2, and then we have a plus c here. Now, I did separate it, but then it actually is together. I can write it together as one big fraction as 4 times 3 to the 5x to the fourth power minus 2 over natural log of 3 plus c. Either way works for me, but that is our final answer. We're given this problem right here, the integral of 2 over x times a negative 1 plus natural log of 4x dx, and a u value of negative 1 plus natural log of 4x. and we have to evaluate this indefinite integral. First thing I want to do here is find my du. So the derivative here, the derivative of our u value, -1, don't worry about that, natural log of 4x. Well, that's going to be 1 over the inside, 4x, times the derivative of the inside, which is 4. 4's cancel, and we just have 1 over x. Not too bad. So now we want to rewrite this in terms of our u values, really. Now, notice the u value is just right here in the denominator. We have the 1 over x, great, that's right there, that's our du, but that 2 is pesky. But I can just pull it to the outside of the integral. So if I do that, I have 2 times the integral of 1 over x times the -1 plus natural log of 4x dx. And now we can replace this with some u's. 2 stays on the outside here. The integral, well, of 1 over, here's our u value down here, and then 1 over x dx is just the du. Not too bad. Now we can use one of our definitions. The integral of 1 over u du is a natural log of the absolute value of u plus c. So we do that, we have the 2 out here times the natural log of the absolute value of u plus c, and we're almost there. We just need to plug our u value back in. We have a -1 plus natural log of 4x. So 2 times the natural log absolute value of -1 plus the natural log of 4x here, and then plus c. And so again, our final answer here is 2 natural log of the absolute value of -1 plus natural log of 4x, then the plus c. We're given this problem right here, the integral of 12x to the second power over x cubed plus 2 dx, and we have to evaluate this indefinite integral. The first thing is I want to find a u value here, and I'm going to set my u value to be the denominator, x to the third plus 2. Okay? Now, let's go find the du. Derivative here, power rule, 3 comes down, 3x squared, and then I have, well, constant 0, a dx. Now, luckily for us, that 3x squared almost looks like the numerator. Okay? Well, how can I make it look like the numerator? Well, if I just pull out a 4 from the 12, I'm left with that 3 there. So, if I do that, let's pull out the 4, and I have the integral now of 3x squared over an x cubed plus 2 dx. Notice the denominator here is that u value again, and these two parts, the numerator and the dx, is our du. And now we can directly substitute in u right there, in du. So 4 times the integral here, instead of x cubed plus 2, we'll put a u in the denominator, and then instead of 3x squared dx, that's just my du. And this is a much easier problem to solve. We have to use our definitions. So 4 stays there, but the integral of 1 over u du is just the natural log of the absolute value of u, then plus c. Well, then from there we can plug x cubed plus 2 back in for u. So we have 4 times the natural log absolute value of x cubed plus 2, then plus c right there. And that's it. So my final answer here is 4 times the natural log of the absolute value of x cubed plus 2 plus c. We're given this problem right here, the integral of 20e to the 5x over e to the 5x plus 3 dx, and we have to evaluate this indefinite integral. Now we first need to find a u value here, and I actually like to deal with my denominator here. I'm going to set my u to be the denominator, e to the 5x power plus 3. Now we want to derive this and see if we can kind of shape our function here. So we have du, the derivative here of, well, e to the 5x plus 3, derivative of the top part, 5x is 5. Then we have e to the u again, e to the 5x right there. Don't worry about plus 3, and dx. Okay? Now we're very close there to our numerator, except there's a 20 and then there's a 5. If I pull out a 4 from the 20, the constant, I'm left with a 5e to the 5x over e to the 5x plus 3 dx. And now it kind of lines up pretty good. This denominator here is my u value, and these two together is my du value. And so now we can rewrite this in terms of u. 4 times the integral here of 1 over u du, right? 5e to the 5x power dx is my du, and then u is just there in the denominator. Now we can use our definitions here. Integral of 1 over u du is the natural log of the absolute value of u plus c. So 4 stays out here times the natural log of the absolute value of u plus c. And now we just have to plug u back in. So if 4 stays out there, natural log, absolute value, our u value from the beginning, e to the 5x plus 3 down here. Then we have, don't forget it, the plus c. And that's it. Our final answer again is 4 natural log, absolute value of e to the 5x plus 3 plus c. We're given this problem right here, the integral of 10 times sine of negative 2x times e to the cosine of negative 2x dx. And we have to evaluate this indefinite integral. Well, I want to find a u value here, and I generally pick the more complicated part, and that's going to be up here in that exponent, cosine of a negative 2x. Well, from there, I need to find the derivative of this, my du. Okay? A little tricky, keep your negatives in line. We know it's going to be a negative sign, right? Derivative of cosine is negative sign of the inside, negative 2x. And then we multiply that by the derivative of the outside, derivative of the inside, negative 2x, which is a negative 2. Well, the negative and negative cancel out, and we got a positive going on right there. Okay? Oh, and don't forget the dx. Okay? So now we have to rewrite this in something with terms of u, and we're very close. We have a u value right up here, looking great, and sine of negative 2x right there, dx, almost lines up, but I have a 2, and there's a 10. If I pull out a 5 from the 10, I'm left with 2 sine of a negative 2x, and then it's multiplied by e to the cosine of negative 2x dx. And now I have it lined up pretty good. Again, this is my u value right here, and my du, right, combine these two items, come together to be that du, right, 2 sine of negative 2x dx. So let's go write this in terms of u. 5 times the integral, well, we just have e to the u power, and then a du right there. Well, keep on going. Let's go integrate that. Now, luckily, our definition's a pretty easy one. 5 stays out front, and the integral of e to the u is, well, e to the u plus c. So 5 times e to the u plus c. Keep on going here. We have 5 times, we're going to plug what we have u in, cosine of negative 2x for that u. So we have e to the cosine of negative 2x here, and then don't forget again, plus c. So again, my final answer here, not too bad, 5 times e to the cosine of negative 2x power plus c. We're given this problem right here, the integral of 5 times e to the negative 3 plus natural log of 3x power all over x dx, and we have to evaluate this indefinite integral. I first want to find a u value. Now, I like to pick something pretty complicated, or the most complicated part kind of entrenched within this problem. And that would be the negative 3 plus natural log of 3x. Let's go find the derivative, du. Well, derivative negative 3, nothing, don't worry about it, it's a constant. Well, natural log of 3x is going to be 1 over 3x times the derivative of the inside, which is, well, a 3. And then that's a dx right there. Now notice 3's cancel. So we just have a 1 over x dx. Not too bad. Now from here, what we want to do is we're going to see if we can rewrite this in terms of u and a du. And we're very close. The top part here clearly is my u, and then the 1 over x dx is my du. But I got a 5. I don't like that. What if I pull the 5 out? I can, it's a constant. So I have 5 times the integral of e to the negative 3 plus natural log of 3x over x dx. And now we have it pretty easy to line up. We have 5 here times the integral, let's write it in terms of u, e to the, remember that's the u power, right there, right? Negative 3 plus natural log of 3x over, well, 1 over x dx was our du. So we just have to write du here, okay? Now, let's go find the integral. Don't get ahead of myself. The integral of e to the u, du, is e to the u plus c. That's the easy one. So 5 stays out here times e to the u plus c. What do we do now? Well, let's go plug what we have for u back in terms of x. So 5e to the u power, which is a negative 3 plus natural log of 3x. And then don't forget the plus c. And that's it. Pretty simple. But my final answer here is 5 times e to the negative 3 plus natural log of 3x power plus c. We're given this problem right here, the integral of 20x to the 4th over 4x to the 5th plus 3 dx. And we're given the u value of 4x to the 5th power plus 3, and we have to evaluate this indefinite integral. Well, we already are given our u value, so let's go find our du value. So the derivative, du, equals 5 times 4 is that 20, power rule here, x, subtract the exponent by 1, and it's a 4, don't worry about the plus 3, and then we have dx. And so here we're trying to see if we can rewrite this derivative with respect to x to be something with respect to u. And notice here, actually, if u is that 4x to the 5th plus 3 in the denominator, and our du is 20x to the 4th dx, we can make this integral look like this. 1 over u du. Notice again, du is that, or 1 times, right, du, same thing, 20x to the 4th dx, and then u is right there in the denominator. That's much easier to solve. Now we can use one of our definitions here. We see it right here that the integral of 1 over u du is equal to the natural log of the absolute value of u plus c. And at this point we can plug back in our u value. So we have the natural log of the absolute value of 4x to the 5th power plus 3, and then all plus c. And so our final answer here is just the natural log of the absolute value of 4x to the 5th power plus 3, and then our plus c at the end. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.